Good afternoon. I was going to say it's nice to see everybody here, but I can see the spotlight. Okay. So if you see me squinting a lot, that's why. It is good to see you here. My talk today is on what to avoid when writing unit tests. We will be looking at some code this afternoon. We'll see if we get some time to run some of the code. It all kind of depends on how much I babble as we go, which can happen. Okay. Good unit tests. They're a critical part of the development process, vital to the life cycle of code under test. Okay, this talk came about primarily because I had a previous employer where there was never enough time for tests. I was specifically told not to write tests. I think in a 6-year window, I wrote 1 unit test. Okay, our code was flaky. That code isn't out in the public anymore, not stable enough. When I came aboard at Leading Edge, where I work at right now, the first project that I was on, I had a language I had to create in JavaScript. What I wound up with was about 180,000 lines of code. I had 97% unit test coverage. So where I learned the value of unit tests was watching that code go live. And over the next year, there were 3 reported bugs. Okay, 180,000 lines of code, 3 reported bugs. And 2 of those wound up being specification issues. You know, in one case, I was told a variable was 12 characters long. Come to find out, somebody had changed it in the system that I was mimicking, and they were actually 25 characters long. I couldn't have done anything about that one, okay? So the reality was 1 bug with solid, good, layered unit tests, okay? In other cases, I've had products where I make sure we have solid layered unit tests. On average, for most projects, I'm seeing 2,000 to 3,000 unit tests plus. I've seen a couple of talks recently, folks talking about, hey, all you really need is 50% coverage. I'm going to disagree with that because I've seen the stability of the code that I write. Okay? So, reiterating, good unit tests are a critical part of the development process, vital to the life cycle of code under test. Okay? I have a mouse here and I'm on the wrong screen. Hang on. There we go. Second slide. All right, so what are unit tests? Okay, I want to make sure I define what we're talking about here. Okay, not talking about integration tests, not talking about QA level tests. We're talking about unit tests, small parts of the application getting tested in isolation. Okay? We're comparing the code under test's actual behavior with the expected behavior. When we talk complete isolation, when we're unit testing, we don't connect our application or our code to external dependencies, databases, file systems, HTTP services. Okay, this allows the unit tests to be fast and stable. Okay, they don't fail because something outside of that code stops working or is broken. Okay. So moving on here. So this slide, I did talk a little bit about how this talk came about from my experience. Okay, the code repository is out there. My name is Bob Fornal, so it's easy enough to see on GitHub. And the title of the talk, What to Avoid When Writing Unit Tests. Okay, I can be found at the Link app. Twitter is rFornal. I write articles on DevTO, again, under rFornal. And on LinkedIn, look at that, rFornal. And my first name is Robert, not Bob. My company calls me Bob, so I use that normally. These have been around for a while. And I talk about the social media project here. One of the things that I've been doing recently is supporting some newer developers in 100 Days of Code and 100 Devs. And what I'd like to ask sometime today is you guys go out and search one of those hashtags on Twitter. There are a lot of folks out there learning about code early on in their experiences. And one of the things that I saw, one of the things I've been trying to do, is I saw a lot of folks that weren't getting any comments on the work that they were doing. They're posting up some really good stuff, or they're posting up about their struggles. And, you know, take a few minutes, go find one or two folks and tell them they're doing a good job. Doesn't have to be anything complicated to cheer somebody on, okay? Just a small ask from me, okay? Now we'll move forward here. Okay, testing code over the years, I've heard it described as an art form. Okay, testing code shouldn't be an art form. Okay, there are a lot of good patterns we can follow. There are also a lot of bad patterns that you might want to avoid. Okay, I've followed a few of the bad patterns along the way. Gotta remember that's there, sorry. And they do cause issues. One of the cases I saw a few years back was the individual hasn't tested that the tests actually failed, right? People here have heard of test-driven development. There's a reason it's popular. When you write the test first, you know it fails. Then you put in the code to make the test pass, right? Had a case where upwards of 2,000 asynchronous tests were written, and nobody ever tested to see that they had failed. It was a 2-month recovery to rewrite those tests to make sure that they could fail if the code had been modified. Okay, that's a big deal. I always like this picture. And we just passed May the 4th, so it kind of made sense to put that up there, right? So, good production code achieves encapsulation, allows the reader to navigate large systems with ease, diving down into the details of the code, rising up, looking at the higher level abstractions as needed. Okay, but when we test code, it's a different beast. Okay, when we test code, good unit tests are often small. Typically, you want to have unit tests that are small enough that you, at a quick glance, you can see all of the logic. Okay, we don't add layers of abstraction into unit tests because it actually increases the code complexity, increases our, it makes it more difficult to understand, would be the easiest way to put that. So tests are diagnostic tools, so they need to be simple and they need to be obvious. Okay, we're going to look at some of the bad patterns, we're going to look at some of the good patterns. We're getting to code, thank you for bearing with me on this, okay? So, well-factored code. All right, this is code that's easy to read and reason about, code that can be tested easily, and is well designed and often has a high level of complexity. Okay, we're going to take a look at a couple examples here. So on the screen you see keep the reader in the test, dare to violate the drive principle. We're going to take a look at those one at a time. So keeping the reader in the test. Here I tell folks, think of rulers. Okay, they've existed in some form for hundreds of years, right? They're not complicated. It's easy to figure out how a ruler works. Okay, if I invented a new ruler that measured in abstract ruler units, to convert from those ruler units to inches or centimeters, you'd need a conversion chart, right? Or these days, some piece of software to do that conversion for us. My assumption would be if I handed that ruler to a carpenter, I'm probably going to get chased out of the room, right? Why add complexity that something should be simple, right? Should be clear, should be unambiguous, okay? So, the code we're going to look at here. Let's take a look at the code, actually. Let me put that up and you guys can see it. go. So this is the first one. Now, I do say, yep, you can see all of that. Good. I do say that this is broken, okay? The code here is not bad code. The test, if I run it, will pass, okay? But what's going on here? If you take a look at the before each that we have down there, we're setting up our database. This is a really complex database, right? It's a tough one. But then you go down and you look at the test. In the test description, we expect the score to be 200. Now in this particular case, I can look, 8 lines up and see where the 200 came from, right? My average test file probably has 30 to 40 unit tests. So if I'm 200-300 lines down and I look at that test at the bottom of the screen there, down here, where does the 200 come from if I don't see the before each on the screen? Okay? Remember, they need to be simple and unambiguous. We want to keep the reader in the test. Okay, so if we take a look at the fixed version of this, notice, first of all, we're a lot shorter. I like that. Okay, we didn't do much in the way of setup. I did shorten that up a little bit. There's not less code, it's just presented differently. Okay, but within that test itself, I'm setting up the database, I'm passing the data in, I'm running my code and checking the result, and guess what? I can clearly, within the test, see where the 200 came from. Okay? I see like 2 heads bopping now, but I can't see the rest of the room, so I guess, oh, I got a thumbs up there, awesome. Okay? So, let's go back to our deck real quick. And next we're gonna look at daring to violate the dry principle, right? If you've been writing code for a while, the dry principle should be pretty straightforward to you, right? Do not repeat yourself. I'm telling other developers I work with when I do pull requests and reviews all the time, don't repeat yourself. Hey, you've done this 3 times, maybe we need to abstract it out. With a unit test, guess what? We break that one, okay? I get to have a lot of fun with this. I get to repeat myself. It's really kind of cool. You actually want to with unit tests, all right? So the code we're going to take a look at, if you're not used to writing unit tests this way, or if you're used to abstracting, this is horrifying code, because guess what? We're going to repeat ourselves over and over and over again, okay? But from a testing standpoint, keeping them in that test, keeping the test coherent and simple and easy, repeating yourself is a better way to do it, okay? So let's take a look at our code for this one. So here's the broken version. We'll take a quick look up here. We got the manager with the database again. We got to get score and adjust score, right? Returns value, gets and allows us to change a value. So I'm going to minimize that down so we can see the test a little bit easier here, okay? So again, we have a before each, setting up that database the way we said was a bad way to do it in the previous example, right? We expect our score to be 200. All right, we already know why that one's wrong. And if you look down below, we're checking that we can adjust the score to 500. This is in a purest sense an abstraction, but we've moved some of the functionality into that before each in a way that we can reuse it within our tests. Okay? Again, it's a bad pattern. It doesn't keep them in the test. We're using that abstraction to make it easier to write our tests, but it's not easier to reason about them. It's not easier to see what's going on individually within the tests. So if we take our look at our fixed versions, our code up at the top of the manager class is the same, but as we come down into our code, notice we don't even have a before each. This is similar to what we saw before when we testing expect the score to be, right? And again, we're doing the same thing again. We're setting up the database and the manager within the test. We're repeating ourselves. But here, we're repeating ourselves for a purpose. The purpose is the tests are now really clear. It's really clear, easy to understand what's going on within that 5 lines of code. Okay? All right, so let's go back to our deck. Yes, I am going to bounce back and forth a lot. And there we go, didn't change. There we go. So, poisoning the code base. Non-deterministic factors. And I'll be honest, when I looked up what I intended to put here and I saw that description, it's a horrible description, right? Non-deterministic factors. So here what we're talking about is at its simplest that we've tightly coupled data. And this tight coupling of data can cause challenges. In this case, we're going to take a look at a test that uses the current date to generate a string value. Based on that current date being the data source, we have to test that the date works right as well as that our code generates the right string from it. Okay, so let's take a look at the code. So our broken version, we have a get time of day, and if we look at this, this is JavaScript. If you're not JavaScript, I apologize. I'm hoping you can still understand what we're seeing here. It shouldn't be too complicated. We're getting the date. We're newing up a date object. We're pulling the hour off of that date, military time 0 to 23. And if the hour's within ranges, we're returning night, morning, afternoon, or evening. Really simple, right? But from a test perspective, look what we have to do. Okay, to set up for this test, we have to bring in the Jasmine clock. And I've learned from experience to uninstall it first and then install it, because it does weird things if you try and do that outside of the individual test. And then we have to create a base time. And then we use the Jasmine clock to mock the date, setting the base time. And then we have to move forward from that time a few milliseconds to get the right response, and we can execute a get to see back if we get back the right string. Now we've done 2 things here. We've set up a mock against the date, as well as attempting to test our function. Okay? So when we talk about poisoning the code base, the problem here isn't in the test. The test becomes a little difficult to understand because the code itself left something in that's non-deterministic. If I didn't mock that date time, what's it going to do? It's going to assume the date time that the function executes. Okay? So we can't determine inherently what it'll be. So let's take a look at the fix. So in this case, the fix is actually fairly easy. We pass in the hour as opposed to generating a date and date time and pulling the hour off of that. We pass it in. We do our if structures and return. Yes, I could have used a switch case. I wrote this kind of fast, but you get the idea, right? And look at our unit test. It's 1 line. Really easy to reason about. We expect that the get time of day, and if I pass it an hour of 1, which a military time would be 0, 100, that's nighttime. And I could pass it anything from a 0 to a 23. We're assuming that somewhere else in the code, we're getting the hour that we're passing into this to get the string out. but it makes our unit test really easy to work with, okay? Not poisoning the code base. So I did like the not poisoning the code base portion, just not the non-deterministic. That's big words for a simple concept. So the next one we look at is another way of poisoning the code base, and this is where we talk about side effects. Okay? In this case, we're going to look at a little more complex code. In this case, a class that's written to turn a light on or off at certain times or with motion. Okay? We are going to see some poisoning of the code base, the tightly coupled calculated date time, and we're going to see that it's directly tied to an additional switch class that causes problems with our code, and this is where our side effects come in. So in this one, we take a little more time because we have a couple pieces going on in the setup. Okay, so we have a switcher class that just has two functions that are turn on, turn off. I would assume that they do more than what we have here in a real production environment, right? I didn't want to get that complex today. Okay, we knew it up, we have switcher. I build this really fancy smart controller that gets a last motion time at the time that the class is instantiated. Okay, we also have a get time of day, and we were smart enough in this case to use the functionality we saw from the last one that was fixed, where we're passing the hour in. Okay, and we have this really long actuate lights function. Now this is where we grab the date time. We also check when it runs if motion detected, which was passed in, is true, or those that know JavaScript in detail, truthy, we're okay with that. If there was motion detected, we update the last motion time. Okay, from the time 2 lines above. We get the time of day. Time of day is that function that we worked with on the last example, right? So if motion was detected and the time of day is evening or night, we want to turn the light on. Otherwise, it gets a little complicated. The time, current time, minus the last motion time is greater than 60,000 milliseconds, 1 minute. Or the time of day is morning, and here, let's drag this over real quick so we can see the right side of that, noon. So if it's morning or noon, we want to turn the light off. Okay? A lot of problems in this code. And my first guess on problems in the code would be examining the unit tests. Okay? First thing that jumps out at me looking at that code, those are really long tests, right? In fact, I always put a space between my setup and where I execute the code and set up my expects. So you can see the setup for these is really long. Like 11 lines long. Okay? We have to do our little Jasmine clock trick, right? We're uninstalling it, we're installing it down in there, we're setting a mock date. Within there, we're also getting a last motion time and a current motion time for use with the clock and with the smart controller itself. So here we're setting the last motion time. We're mocking, excuse me, we're spying on, don't let me say mocking, I'm sorry. We're spying on that turn on and off that came from the switcher. Okay. So what do we have here? We have a lot of side effects in this essentially poison code. The code could be cleaned up. The code can make these tests a whole lot easier. So let's take a look at how that works. So we're going to go down to, there we go. Now, switcher looks the same. Our smart controller, there are some differences. First is we have this get time, get hours functionality that we can now directly test if we needed to. Actuate lights has been simplified. Okay, we can use that get time function right here, and the nice part is we could spy on it. We can fix a forced return value without having to adjust the date time. And notice we also pass into actuate lights the functions for turn on, turn off. So in this case, I could mock out that functionality to see that it triggered at the right dates and times. Okay, so these aren't big changes to the code, right? But those changes to the code let us write much simpler tests. Okay, so look at what we've got going on here. I created a variable, is on. Okay, nothing big, it's a variable within the test suite. I created two functions, turn on, turn off, and for those that don't work with JavaScript regularly, these are arrow functions. So in an arrow function, what you have here is essentially what is the returned value. I could have wrapped it in parens and pushed down, but I was trying to minimize how much space my code took for you guys to look at, okay? In the before each, I'm always setting the is on back to false, making sure it resets, okay? And then within our tests, what all do we have to do? We set a last motion time. It's looking for a difference in milliseconds, so I'm just going to set it to 0 initially. So when we take a value and we subtract, we're subtracting 0, so the value that we pass in to see if we're turning off on and off at the right time, it's just a difference in milliseconds, okay? We spy on, I told you we were going to spy on the get time and the get hours. We're returning specific values. So 20, if we look at our get time a day, is going to return evening, okay? And 60,001 should make this calculation down here come out as true, okay? Just by spying on, executing, passing on the turn on and off that we created up here, we now can see that it didn't turn the light on. It set the light to false, so it triggered the turn off function. Okay, in our second test, we have the 60,001, we have the 20, we have the last motion time, and what did I do differently here? Wow, I'm thinking I might have broken something on that one. Sorry? Yeah, but I'm thinking I might have done something wrong because the setup on these is exactly the same on both. So what I should have had is we need something to say motion detected. Oh, you're right. You did point it out right. I read my code wrong. I apologize. So where the difference is when I actuate the lights. On the first one, I passed in false for motion detected, and the second, I passed in true for motion detected. So we would have seen motion detected. We check our time of day with the hour being 20, and it passes back. It's either evening or night. Then our lights turn on. Good catch, who was paying more attention to my code than I was. Thank you. Okay. They do get confusing now and then, don't they? All right. And this is one I would assume anybody that's written unit tests for any amount of time you've seen. Testing too much. Okay. A lot of times our functions will have switch statements, if blocks. If they're not refactored well, you end up with code with a lot of ways through it, a lot of branches. And for proper unit testing, you should test each of those branches. What I see at times is that people make that into a problem. Let's take a look at testing too much. So in this case, we have a message class. Send email, send text, send queue. We need to figure out which route to send the message. Okay? We have this trigger message that receives a user object. We declare our variable for the message based on the user type, admin, user, author, or other. We set what the message is going to be. And then we have a nice if block at the end based on, again, user, but the preferred notification method. Email, text, or other. Okay, based on that we trigger. Okay, this one function does a lot. We have 4 times 3, 12 paths through the code. Okay, so we do some setup, and you see our tests run. Okay, it's a lot of tests. It's 12 separate tests to properly test one function. Right? So this code is actually doing too much. Okay, meaning we have to do a lot of work to test it properly. So what did I do? Well, I built an object of the types of messages, simplify that a little bit. The get message either gets the specific message type, but if the type's not in the list, it returns the anonymous. Okay, this has 2 paths through. It's easy to test, right? We trigger a message type. We're passing a type and a message because we can know we can get the message. And 3 if blocks to determine which of the 3 messages. So again, we have 3 ways through, but still that's not too bad. And then we have a trigger that really is just 2 functions. And if we spy on a couple things, we can see that the right data is passed around because we test those individual functions in detail above. Okay, so by breaking that code up, what does that do to our tests? Okay, so we set up in our before each, our messaging class, we set up our spies and stub, and then you can see this messaging class, we actually have 4 tests against it, admin, user, author, and something else. We've tested all the branches through. Okay. And then on the trigger error message type, we have 3 tests, testing each of the branches through. And then one kind of a little bit upper level, testing the trigger message instead of the trigger message type. And again, like I said, let's just spy on those and see that the right data is passed around. Because we have those functions tested previously, it's okay to allow that almost an integration test. Okay? From a purist sense, that's not an integration test, but it's showing that we're using those functions correctly. Okay? Here's one that I see all the time, bad test doubles. We do write test doubles. It's okay to use test doubles to isolate correctly. Okay? The danger with test doubles, with mocks, is that you can, if you're not familiar with what you're doing there, start to test the mock itself. Not the actual code that you're intending to isolate by creating that test double. Okay, so let's take a look at code on this one. So our broken code, we've got a data service and a test. I called it test component. It doesn't have anything to do with unit tests. I just needed a name. I needed a component name. Okay, so our data service has this really fancy object, the user Tom, and a function that returns the data. Okay, it's a tough one. And then we have a test component that was going to receive an API service. Not a bad way to set it up. Okay, we're injecting that service when we instantiate, and then we can execute get data that uses the API service to actually retrieve the data. Okay. Try to add a little complexity in, so I'm not boring you too badly, right? So here's our bad test double tests. Sweet. In this case, in the before each, we created a mock result. You know, I like to see my name on my code, so we got Bob in there. Okay, we set up a mock service, and we created a get function that returns that result. Okay, so in this case, we've mocked that whole service, and we created a new component passing in the service. You can see that the test is relatively simple. It's fire and get data. But all we're doing is testing that this can fire this function against our mock. If anything changes up here, we start to run into problems. Okay, we're not actually testing anything other than we're calling the right function. Which, you know, there are scenarios where that can be okay, but in most scenarios, we need to test what's going on here as well, to a degree. Okay, so let's look at the fixed. Nothing changes up here in data service and test component. We're going to create a mock service and a mock result. We're going to create a component. So our mock result, again, me. We're creating our data service. But notice what we did. We used the real data service. We newed that up. Okay. We change data on that new service. That's it. Okay. So what we've now done with this test double is we used the original component, modified the data so we can stably test the functionality. Okay. Our actual unit test doesn't change. Okay. One of the patterns that I see occasionally that come along these lines is that API service is a pure mock. And then something gets added into the functionality in the real API service, and you're expecting that to change. But if throughout the code to isolate, you've created a mock API service, you lose a lot of that functionality, and errors can crop in that are unexpected. Okay, so you got to be very careful about how those mocks, those test doubles are created and used. Okay. The next one we're going to talk about here are false positives. And I think I mentioned the example early on, false positives. With front-end code, we deal with asynchronous activity a lot, right? And it's very easy with asynchronous activity to create a test that falsely passes, okay? These also occur at times if you forget to put an expect in. Now, I will say with most test suites these days, if you forget to put an expect in, you at least get a warning. But your tests don't fail. And if your CI/CD platform isn't watching for those warnings, your tests are still passing, even if you don't have an expect. Okay? Now, in my code here, I'm going to get to it in a second, there's a whole section that's commented out. Okay? I have the actual code in here that 3 months ago would falsely pass. Jasmine and Jest front-end test suites are actually working on fixing this actively right now. Okay, so my tests don't falsely pass, but they're not failing at the right time anymore either, and they've got a whole new pattern that they're asking us to use. So I went with the new pattern with my code. So let's look at the broken. We have testable code, and for those of you who worked with front end for a while or haven't worked with front end, I'm going to apologize with what we're doing here because this is kind of ugly in our testable code. We're getting a rejected promise. This should reject after 1 second and should cause a test to fail. Right? Pretty straightforward code, a little ugly. Okay. So remember I said no expect. This doesn't fail. There's no expect. It is a warning. Okay, we need to test what's going on inside a set timeout. This passes. Because the expect doesn't trigger before the end of the test run. So essentially, it's treated as no expect. And here, the rejection should occur. And notice we checked for should equal failed, but we have fail. And guess what? This passes. Now, this passes because our function's not asynchronous. If you've worked with JavaScript for a while, we have async await. Okay? None of these are asynchronous. They're not waiting to the completion. So let's take a look at fixed. Here's my commented out code piece. Testable code hasn't changed. Guess what? We now have expect, so that will properly pass. Okay. No warnings in that case. Inside the set timeout, I did this the hard way. We used the Jasmine clock. We could have used async await, maybe. This is what we used to write as the correct pattern that no longer passes, fails correctly. It gives us a warning. Okay, this is what's mid-process on getting fixed in the modern Jasmine and Jest frameworks, where we have a then, and we're checking for it to expect to pass, and a done. Okay, in this particular case, if we uncomment, what we get is, hey, we have done in there twice, and you're not allowed to do that. Okay, but here's the pattern that they're asking us to use now. Notice the async await. Okay, so we set up the async, we set up our clock tick timer stuff. We know it was 1,000 milliseconds, 1 second, so we went past that. We set up a try catch around the async await. We set our result to the await on await promise that we set up above. Okay, so it's a promise. We have to wait for that to finish what the async await allows us to do. Okay, I did test, I mean, in my mind, logically, it would have been, hey, let's put this code down here where wait promises on line 53. Well, that doesn't work because it's outside the timer and does really weird stuff. Not sure why, but this is what they're recommending at the moment. I'm hoping they fix it quickly and I can adjust my talk. Here's one many of you should have seen: excessive setup. Okay. This is a tough one to show examples of. I'd rather show real code, and well, I work for clients, I can't show off their code, right? So I did my best here to come up with some examples, and let's take a look at what we have. So excessive setup. All right, so we have this car service, nothing complicated. We're getting average mile per gallon based on a brand passed in. We're getting a list that we then filter for a particular brand. So a couple little things going on, nothing complicated. But notice our setup on this one is a little lengthy. In this case, it's not a lot lengthy. Okay, this is enough to show an example of how we can fix it. Excessive test setup. I've seen tests with 200, 300, 400 lines of code to set up. I mean, it takes you 20 minutes just to figure out what's going on in the setup. If you've got that much setup that has to occur to properly test your code, odds are you got something either significantly wrong with your tests or significantly wrong with your code, right? Anytime you see those long continuous chunks, you should be questioning. One of those two sides has a problem, okay? This one's not excessive. I've seen ones that are 20, 30 times this, okay? But it does allow for a relatively easy test. In this case, the excessive setup made the testing easier, okay? So let's go look at the fixed. We have the same car service, nothing has changed there. But look at our setup. We just knew the car service, and we're passing in some information. We relied on the internal information already built into the class. It clearly wasn't needed, okay? I tried to come up with a simple example of this. You guys will have to let me know after whether that one succeeded or not, okay? So, last one. Testing private functionality directly. In this particular case, this is one of the more challenging ones because in JavaScript, we just recently got private on classes, like within the last 6 months. And it's not real well known and it's not real well used, but one of the questions I get a lot of times is, hey, I've got all these private functions within my class, how do I test it? Right? Seems pretty straightforward. It's private. You shouldn't be able to access it once the class is instantiated. There basically are 3 ways, okay? You test it through the exposed functionality. You have to test it kind of from the edges. You can make those functions public, which always brings up these massive debates on whether we should make them public. Usually they're private for a reason, correct? The other one that I've been able to talk a few folks into that are really have real strong opinions on the public-private is, can we pull those out into another service that then gets injected in? They're treated as private within our current set of code that we're testing, but then that secondary service is testable on its own because they have to be public for the service you're injecting it into to test it, okay? So let's take a look at this code. Okay, this is the longest one. So we have a user service, we have users. Here's how we set private on a class in JavaScript. Yes, it's ugly. I get it. We're still working on it. Okay, for those that aren't front-end it'll improve over time. We have a set state, takes a name and a state, okay? And clearly we have the state over here that we can change. We have a delayed process, okay, and it's private, so how do we test that? Well, delayed process is fired by this trigger down here, okay? We have a set user, get user, and a trigger delayed. They use all that private functionality up above, right? So the questions are always, how do we test set state? How do we test delayed? And in this particular case, as I wrote the tests, I tested them around the edges. I used the exposed functionality to test it, okay? And yes, I have a fixed, and this is not the only way to do it, okay? Nothing up here has changed significantly, except I did take this visible set timeout handler that's then injected inside the set timeout. So while I can't test delayed process directly, I can test what happens inside that set timeout directly. Okay, so what I'm saying here is there's no perfect answer. Okay, I use this pattern within Angular a lot when I'm connecting to observables. I'll bind in another function because I can test that function on what happens to the data that's passed through the observable directly without having to set up an observable. I can just test that function, okay? There isn't always a perfect answer on this one. You've got to find what your organization, what your developers are comfortable with, okay? Sometimes it's testing indirectly. Sometimes it's like this, where we pull some parts of it out to be able to test directly. And sometimes it might involve having separate classes that expose that private functionality in a way that we can then test it directly, okay? So, done with code, and we're down to 8 minutes. Unit test recommendations are pretty simple, okay? Unit tests should be readable. I mean, that's the first thing. If I'm looking through a unit test that somebody's working on when I'm reviewing, and it takes me more than a few seconds to figure out what's going on, I need to stop, step back, and question whether there's a bigger problem going on within the code or within the test. One assert per test method, I get asked about this one a lot, and I do break that one at times. You attempt to have one assert per test, okay? I try my best to do it. I still have some tests that have 3 asserts here and there in my code. Sometimes it comes down to time and getting things done appropriately and quickly too, okay? We still have good tests against the code. Avoid test interdependence. This is one that's bit me before, where, you know, when the tests run randomly, random order, all of a sudden we get functionality that there are tests that start failing against the functionality because they're in some dependent order. You know that in the previous test we changed the username, so now we're looking for that new username. If that kind of thing is going on, you've got some real problems in the test. Okay, you should be resetting back to 0 each time. Okay, keep it short, sweet, and visible. The lengthier it is, the more you should be questioning that you're validly testing the code properly. And add your tests to the build. If you have a build pipeline, your tests need to be in there. It is awesome protection for yourself, okay? I have pushed code up and forgot to run my tests and something was broken. And it was great to see that it was broken. I'm happy for that one. I do that probably once or twice a month. It's wonderful to have my pipeline tell me I screwed up and forgot to run my tests. Excuse the language. Okay? That's an amazing feeling. All right? I did tell Larry out at the booth out there that I put this in my slide deck, so we are hiring. Don't come see me, go see Larry. Okay? You can come see me if you want to. I'm much nicer than Larry is. And time for questions. And I can't see you, so if you raise a hand, just yell really loud. There is a hand up there, yes. So when do you decide to use before eaches or not? I would say the majority of the time, I'm not injecting new code into my before each. I would rather have it in the tests, okay? Most of your libraries and frameworks, so Angular, React, that kind of thing, have set up code that automatically gets installed in there that sets up the component, that sets up the service. I don't usually change that. I don't generally want to inject data unless there's a specific need for it. I do have a couple of pages that are looking for an ID that gets injected in via data point. Okay, so we have to pass something in for that component to actually get instantiated correctly. Okay, but I do that as infrequently as possible. So I stay out of the before each and after each, if at all possible. Good question. Did I repeat the question? I don't remember if I repeated the question. Well, I'm going to repeat the question again because I don't remember if I repeated the question. The question was how frequently we should use the before each, because in my earlier slides I was taking it out of the before each. In the later slides I was using the before each, and I had some data points and things injected in there. So sorry, I know I'm supposed to repeat. Anything else? Okay, trying to check, make sure the upper corner, nobody's got hands up there, nothing on Slack. Thank you for coming. Enjoy your lunch.